Hello everybody, this is Todd Frazee again, and this is the video tutorial to develop the CAD model for the S60-111 part called the primary piston cap. This is for the Sterling 60 series. And once again, you can download the drawing here. It's Sterling, so that stands for Sterling 60, and the revision number. It's possible that the revision may be updated and may not match this video, but make sure that your file name matches the revision of the drawing that you are given. This is very similar to the last two parts that you should have already developed, but we are going to use a different technique for this so that you're learning more than one technique to develop these parts. Okay, and when you're done, don't forget to come back to this screen and submit your solid part file. Okay, so we're going to SolidWorks. If you're first booting up, the window might look a little different, but you definitely want to select that you're creating a new part number. And we're going to hit OK. And you should have a screen that defaults to something like this. And as habit is, we're going to initially save off. And we're going to save off the file with the matching number to the drawing. So S60-111, I'm going to check the revision is 0 for the drawing I have, and your first initial and last name. Okay, let's save. And then, as we have been, we're going to turn the planes on. A faster way to turn the visibility of the planes on and off is to pick on this eye icon and display them through that. And it toggles all the planes on or off. If you wanted to toggle individual planes, you can pick on them on the feature history here. Alright, so we're going to start off with the planes visible. And then we'll go back to our drawing. And in our front view, we have the, I would call this a front view with a left side view. So this would be our front view, and we're going to draw it on the front view. And our large diameter is 0.422. So let's go back to SolidWorks, and we're going to go into Sketch Workspace. We're going to select the sketch icon, and it's asking select the plane in which you want to create your sketch. So I'm going to set up the same way the drawing was. I'll pick on the front plane, and it turns it so that your viewing plane is 90 degrees to the plane, or what is called normal. So we were looking at the plane in the normal view. And we're going to create a single circle starting on the origin and drag it out. Now if you do it correctly and you select it on origin, it should automatically make a relation between the center of the circle and origin, so that's at least anchored in 3D space. Okay, now we're going to go to our smart dimensions, and we're going to tell SolidWorks what is the diameter of this. And it's, we'll go back to our drawing, it's 0.422. So we're going to type in 0.422. And we're going to select the green check mark. It should turn black. And we're going to accept that dimension. And we're actually this time going to exit the sketch. Okay, now that we've exited the sketch, we're going to go to Features, and we're going to create a boss extrude off that sketch, which if you already have it highlighted, it's going to take the sketch that you have highlighted. Okay, and we need to put in the thickness of this part. So our part is a primary piston cap. It looks kind of like a washer and has a thickness of 0.16. Okay, so we're going to put 0.16 is our depth, and we're going to accept that. And we end up with a puck that's that thickness and diameter, matching our drawing. Okay, so we're going to put in the hole using a different method. If we go back to our drawing, we have a hole that is 0.099 to 0.094. So it has a 5/1000 range that it can be within. Okay, so there's a couple ways you can create that feature, and in this tutorial I'm going to show you how to use an extruded cut to make this feature. Okay, and we have to figure out what the nominal average of the tolerance is. So this dimension, the actual center of the tolerance is 0.0965 is the center of tolerance. So that's the size we actually want to draw the circle. Okay, so 0.0965 or 96,005 in machinist language. Okay, so we're going to go sketch, and this time instead of picking on a theoretical plane, we're actually going to pick on a plane represented on the part itself. So I'm going to pick the top of this part, and so I'm going to press sketch, and I'm going to pick on the top of this part, which will be the plane that we're working in. I'm going to go to a viewing angle of normal to the selected sketch plane. And you notice I have my sketch with a negative symbol because there's nothing constrained on it. We're going to draw our circle, and we're going to select on origin. And bring our circle out. Now, to double check we select that correctly, exit the drawing tool and try to pull on the center of the circle, and if it moves then you're not aligned with the origin. Alright, we now have a circle, and we're going to put a dimension on that circle. And we're going to drag to the right, and we're going to put in 0.0965, which is the diameter of our hole. Now, if you recall, we did a rod in an earlier model, and it actually gets soldered into this hole here, and so that's where there's the difference in size. So we're going to accept that, and it's rounding it up to 0.01, but we're going to change our display to go to 3 decimal points, and it actually has another decimal point beyond that. And then we're going to set, as good practice, the tolerance of the limit dimension to match the drawing, and we're going to put, we have plus 0.0025, which is 2.5 thousandths, it's half the tolerance, 0.0025 there. So we should get the same range that we had on the drawing. And we actually do need to switch back the tolerance. I slipped the wrong box, but to 3 place decimal points. I meant to have you select that one. Okay, but we can verify our number down here in the lower box under primary value. The actual number is 0.0965 is what our median of the tolerance is. Okay, that's all good. Our second sketch doesn't have a negative symbol by it anymore. And what we can do now is exit the sketch and make sure it's still highlighted. And I'm going to go to a 3-dimensional view, and by just rotating the screen a little bit. And we're going to go to features. And instead of doing an extruded boss, we now have these other options over here. We're going to do an extruded cut. And that allows us to cut material away. And it's going to default in the direction where it senses there is material. And in this case, you can either punch in a value, which would be the thickness of the part, or if you can choose the option through all. There's a bunch of different options here. But through all is going to go all the way through the part. The advantage of that, as opposed to putting in a punched in dimension, is if you decide, hey, I need to change the thickness of this cap, and you punched in a number, you're going to have to go fix that number in 2 places. If you say through all, no matter what thickness this model is, that hole will always go all the way through the part, if that's your design intent, which it is in this case. So let's accept that, and we've pretty much finished the next model. That is the dash 111 part. If you want to, go ahead and set your material to brass. I'm going to go ahead and do it because it's kind of neat to see that when you bring all the parts together, that they're represented in a color that's relatively close. So we're on a copper alloys, and we're just going to pick standard old brass, okay? Because our drawing says this is made out of C60-111 brass, half hard. We're going to apply that. And it changes to more of a brass color. Okay, I'm going to go ahead and hide my planes since I don't need them anymore. And make sure you save your part on your H drive. And then go back to Canvas into the assignment and submit it here. Alright, thanks a lot. That's the next part, and we'll see you on the next one.